Kubernetes. Course title: Kubernetes Fundamentals. Course description: this course introduces Kubernetes, an open-source container orchestration platform that automates the deployment, scaling, and management of containerized applications. Students will learn how to use Kubernetes to manage containerized applications, including deploying and scaling applications, managing storage and networking, and implementing security and monitoring. The course also covers best practices for containerization and microservices architecture. Module 1: Introduction to Kubernetes. Overview of Kubernetes. Kubernetes is an open-source container orchestration platform that automates the deployment, scaling, and management of containerized applications. It was originally developed by Google and is now maintained by the Cloud Native Computing Foundation, CNCF. Kubernetes provides a platform-agnostic way to manage containerized applications, allowing developers to deploy and manage applications across different environments, such as on-premises data centers, public cloud providers, and hybrid cloud environments. It is designed to work with a variety of container runtimes, including Docker, Containered, and CRIO. Overall, Kubernetes provides a powerful and flexible platform for managing containerized applications at scale, allowing developers to focus on building and shipping software rather than managing infrastructure. Architecture of Kubernetes. The architecture of Kubernetes is based on a master worker model, where a set of master nodes manage a set of worker nodes that run the containerized applications. The master nodes are responsible for managing the state of the cluster and scheduling workloads on the worker nodes. The key components of a Kubernetes cluster are: 1. Master nodes. The master nodes are responsible for managing the state of the cluster and scheduling workloads on the worker nodes. The master nodes run a set of control plane components, including the API server, scheduler, and controller manager. 2. API server. The API server provides a RESTful API for managing the state of the Kubernetes cluster. It receives and processes API requests from kubectl and other Kubernetes components. 3. ect. ect is a distributed key-value store used to store the state of the Kubernetes cluster. It stores configuration data and metadata about the objects in the cluster. The architecture of Kubernetes is highly modular and extensible, allowing developers and operators to customize the platform to meet their specific needs. Kubernetes components and APIs. Kubernetes has several core components and APIs that work together to manage containerized applications. 1. API server. The Kubernetes API server is the central management point for the entire cluster. It exposes a RESTful API that can be used to interact with Kubernetes and its resources. All components in the cluster interact with the API server to get information about the state of the cluster, update the state of the cluster, and perform various other functions. 2. ect. ect is a distributed key-value store that is used to store the configuration data and state of Kubernetes. It is responsible for maintaining consistency and providing high availability for the Kubernetes cluster. 3. Controller manager. The controller manager is responsible for managing the various controllers that run in the Kubernetes cluster. These controllers monitor the state of the cluster and take corrective action if necessary to ensure that the cluster is in the desired state. Examples of controllers include the replica set controller, deployment controller, and stateful set controller. 4. Scheduler. The scheduler is responsible for assigning workloads to nodes in the cluster based on resource availability, workload requirements, and other factors. The scheduler examines the state of the cluster and determines the best node to run each workload on. Kubernetes also has a wide range of APIs, including the Kubernetes API, the Container Runtime Interface, CRI, and the Cloud Controller Manager, CCM, API. These APIs allow developers and operators to interact with Kubernetes and its resources using a variety of programming languages and tools. Module 2: Deploying Applications. Containerization and Microservices. Containerization and microservices are two concepts that are closely related and are often used together in modern software development. Containerization is the process of packaging an application and its dependencies into a lightweight, portable container that can run consistently across different environments. Containers are isolated from each other and from the host system, making them a secure and reliable way to deploy applications. Docker is one of the most popular containerization platforms, but there are other options available, such as Podman, LXD, and RKT. Microservices architecture can be challenging to implement and manage because it requires a high degree of coordination and communication between the different services. Containerization, however, simplifies the process by providing a consistent and reliable way to package and deploy microservices. Together, containerization and microservices provide a powerful and flexible approach to building modern, cloud-native applications that can meet the demands of today's rapidly evolving business environment. Deploying applications on Kubernetes. Deploying applications on Kubernetes involves several steps, including creating a deployment, defining a service, and exposing the service to the Internet. Here are the general steps for deploying an application on Kubernetes. 1. Containerize your application. Before deploying your application to Kubernetes, you need to containerize it using a containerization platform such as Docker. A containerized application consists of a Docker image that contains the application code and all its dependencies. 2. Create a Kubernetes deployment. A deployment is a Kubernetes object that manages the desired state of a set of pods. To create a deployment, you need to define a Kubernetes manifest in YAML format that specifies the desired state of your application. This manifest should include the Docker image, the number of replicas, and other configuration options. In summary, deploying applications on Kubernetes involves containerizing the application, creating a deployment, defining a service, exposing the service to the Internet, and testing and monitoring the application. Kubernetes provides a powerful and flexible platform for deploying and managing applications at scale, making it an ideal choice for modern, cloud-native applications. Creating pods and deployments. In Kubernetes, pods are the smallest and simplest unit of deployment. A pod is a logical host for one or more containers that share the same network namespace and storage volumes. Deployments, on the other hand, are Kubernetes objects that manage the deployment and scaling of a set of identical pods. Here are the general steps for creating pods and deployments in Kubernetes. 1. Create a container image. Before creating a pod or deployment, you need to create a container image that contains your application code and all its dependencies. You can create a container image using a containerization platform such as Docker. 2. Write a pod manifest. A pod manifest is a YAML file that describes the desired state of a pod. The manifest should include the container image, the container port, and other configuration options. You can create the manifest file manually or using a tool such as kubectl. 3. Create a pod. Once you have written the pod manifest, you can create the pod by running the kubectl create command and specifying the path to the manifest file. This will create a single instance of the pod. 4. Write a deployment manifest. A deployment manifest is a YAML file that describes the desired state of a set of pods. The manifest should include the number of replicas, the pod template, and other configuration options. In summary, creating pods and deployments in Kubernetes involves creating a container image, writing a pod or deployment manifest, and using kubectl to create or update the pod or deployment. Kubernetes provides a powerful and flexible platform for deploying and scaling containerized applications, making it an ideal choice for modern, cloud-native applications. Thanks for watching. For more information, like, comment, and subscribe our channel.